Hey everyone, welcome back to this channel. Let's continue our EDA session. In our last class, we understood how to remove any outliers from a dataset. Now, in this session, we are going to learn how to mitigate the effect of outliers. That means the outliers will not be removed from the dataset. Instead, their effects will be mitigated. Okay. Now, first of all, let me tell you what is an outlier. You already know outliers are those data points which are significantly different from other data points. They may be either very high or very low in comparison with the other data points in that data set. Clear? Now, in some scenario, you may need that outliers must not be removed. Instead, their effects can be mitigated. That may happen due to any reason. Like maybe the other features are important or removing those outliers may create different kind of bias. So in those scenario, you cannot remove the outliers. You can simply mitigate their effect by applying log transformation. You know what is log transformations? Log transformations are very powerful technique to reduce the impact of outliers. If you apply logarithms on any numbers, that numbers gets reduced. So it can compress a range of values. When your dataset has some outlier, that means the dataset has a high range because the low value, the minimum value is very low and the maximum value is very high. So the range of the dataset is very high. Okay. So logarithms will make the range small, will compress that range. So the outliers will become less extreme and it will have less effect on the data set. Okay, so now let's learn how we can do this. Okay, now first let me create a data set for you. Import numpy as np, import pandas as pd, import cword as SNS. Let me run this. Okay, now I will create a data set. So write data 8 equals to, now I'll create two column. One is house ID. In the house ID, use a range value because I want to generate 100 numbers. So 1 to 101. Okay. Now in the second column, price. So in the price range, I'll write np dot random dot normal distribution. I'll generate 300 mean value, 50 standard deviation, and 95 outliers. Sorry, 95 points, normal points. With that, I want 5 outliers. So I will write np dot random dot normal. Uh, make the mean value 5000, make the standard deviation 1000, and 5 outliers. Total 100 points. Okay. Now what I will do? I will concatenate these two data sets. So I can write np dot concatenate function which concatenates two values and here. Okay. Sorry. Um, Fine. Now run it. Convert it into a data frame. So write df8 equals to pd dot data frame data 8. Okay. Now let's run it. Just check the data set. df8. See the price column. Okay, so you will get 5 values having outliers and 95 values are normal. Now, if you want, you can identify the outliers by creating a box plot, and interquartile range also you can use to check how many outliers are present in the dataset. We will not do this in this session because we already did in the last session. If you have any confusion, just watch that video. Okay. Anyway, we will do a KD plot here. KDE plot of the price column. So BF8 price. KDE plot we learned while studying C1 library. If you have confusion, watch that video. Anyway, give said equals to true. Now see, you have outliers. Fine. Now let's apply logarithms on this. So I will write np dot logarithm on the df8 price column. Okay, now if I run it, see. See, you can see the values. Here, the values, this has been reduced. Okay, the range is very small now. If you want, just let me keep it in df8 price column. If I write price equals to you stored here. Now df8 price column. Okay. Now if you want to check the describe, then you can simply write df8 dot describe function. Now see here, the standard deviation is very low. Mean value is 5.85. Maximum is 8. Okay. Earlier it was like, let me show it to you here. df8 dot describe. Now if I run it, sorry, it has been changed. So I have to run this again. Now if I run it, now see. Now see, the mean value was 504. The max value was 5538. The minimum value was 184. And the standard deviation was 915. Okay, so from here you can easily check that it has outliers. But here I have to run the things again. Um, Now see, the range has been reduced. Okay, see the changes in the mean value in the standard deviation has become less than 1. The maximum value. Clear? Now if you want, you can uh, create a KDE plot. KDE plot on DFA on price column. So here I have to write set equals to true. Now if I run this, see it has also changed. Earlier it was like that only, more distorted, more skewed. Now it has been changed. Okay. So you can understand that without removing outliers, you can remove the effect of these outliers. Now, if you apply any model on this data set, it will be able to give you better results than before. Okay. So in those scenarios where you cannot remove the outliers, you can mitigate the outliers. But remember one thing, that if your data set is right skewed, then only you will be able to apply logarithms. If your data set is left skewed, then it will not give you a good result. Okay, you should not apply logarithms on that. Fine. Okay, so we have understood the things. This is a very simple topic. We will meet in our next video. Till then, bye. Happy learning.